Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Students, if you are new to our channel, don't forget to subscribe. To be helpful to other students, keep share our videos and like our videos so others can be benefited with this. Now student, in our last video, we discussed the basic problems of inverse trigonometric functions. That is especially based on principal values of inverse trigonometric functions. Student, in today's video, we'll start some other problems where properties of inverse trigonometric functions. In today's video, we'll solve some standard problems of inverse trigonometric function based on some standard properties. The first problem is prove that tan inverse 2 by 11 plus tan inverse 7 by 24 is equals to tan inverse half. Okay, student, here we should prove that sum of the two tan inverse term is equals to tan inverse half. Student, here we can use a property called, or you can call it as formula also, tan inverse x plus tan inverse y formula. So first let me take LHS. Tan inverse 2 by 11 plus tan inverse 7 by 24. Student, tan inverse x plus tan inverse y. We know what is tan inverse x plus tan inverse y. It is tan inverse of x plus y divided by 1 minus x into y. So let me consider this is our x and this is our y. So with this, the formula of tan inverse x plus tan inverse y is tan inverse of x plus y. Tan inverse of x plus y whole divided by 1 minus x into y. Student, this is the formula for tan inverse x plus y. Tan inverse of x plus y divided by 1 minus x into y. Next, we must take LCM, no doubt it. Now, tan inverse of, what is LCM in numerator? 11 into 24 is LCM. So, this becomes 48 plus 77 divided by 11 into 24. So, that is 264 divided by 11 into 24 is LCM here. So multiplied by 1. 264 minus 2 into 7. It is 14 divided by 264. Now student, here denominators are same. So it gets cancelled. So what do I get? I'll get tan inverse 48 plus 77. How much it is? 5, 120, that is 12 divided by, no denominator, so it gets cancelled. Just 264 minus 14 is there. So it is 250 in the denominator. Student, this can be cancelled by 1 time and 2 times. So at the end, what do I get? I get tan inverse of 1 divided by 2. This is my RHS. Since the problems are very simple, just we should memorize the formulas or properties, and based on this kind of problems, they will ask one question in your final exam for 3 marks. Okay students, now let us go to the next problem. Prove that two tan inverse 1 by 2 plus tan inverse 1 by 7 is equals to tan inverse 31 by 17. Now student, here we have a coefficient of tan inverse term. So for this particular term, we can use the formula or property of 2 tan inverse x. After that, we will involve this also. Then again, we will use tan inverse x plus tan inverse y formula. LHS is equals to 2 tan inverse of plus tan inverse of 1 by 7. So student, first I will use the property for this. Right here. 2 tan inverse x can be written as tan inverse 2x divided by 1 minus x square. So here 2 tan inverse can also be written like this. So that 2 tan inverse x value is half. That can be written as tan inverse 2x divided by 1 minus x square. Then plus this tan inverse 1 by 7 as it is. No changes. Just I will keep adding this. Now student, this and this gets cancelled. So next step is tan inverse 1 divided by 1 minus 1 by 4. That is 1 by 2 whole square is 1 by 4 plus tan inverse 1 by 7. Now next student, I must take LCM here. 4 is the LCM. Tan inverse of 1 divided by, if 4 is the LCM, 4 minus 1 is 3. 3 by 4 plus tan inverse 1 by 7. Now 1 by 3 by 4 is 4 by 3. Tan inverse of 4 by 3 plus tan inverse of 1 by 7. Now student, at this position we can use the formula of tan inverse x plus tan inverse y. So now this term I will consider this is my x, this is my y. So again I should use the same formula, that is tan inverse x plus tan inverse y formula. What the formula says? It says that it is tan inverse x plus y divided by 1 minus x into y. So LCM we must take. 3 into 7 is the LCM, that is 21. So it is tan inverse of 7 into 4, it is 28 plus 1 into 3, it is 3, divided by 21 whole divided by in the denominator 3 into 7 is our LCM in the denominator, so 21 into 1 is 21 minus 4 divided by 21. So now student, this 21 and this 21 gets cancelled. Now what is left out? The left out part is tan inverse 28 plus 3. It is 31 divided by, in the denominator what we have? 21 minus 4, because this 21 and 21 gets cancelled. 21 minus 4, it is 17. Now student, just check, this is our RHS. Okay student, these are very important problem based on tan inverse x plus tan inverse y formulas. Now let us go to the different type of problems where we have a function and let us try to write the simplest form of this function, the given function. This is also very important for 3 marks. They will ask this kind of problems also. So under that, the first problem is, and the question will start like this itself. Write the simplest form of the function. Write the simplest form of tan inverse root of 1 plus x square minus 1 all divided by x. Where x is not equal to 0. X not equal to 0. This root is only for 1 plus x square. This root is only for 1 plus x square. This minus is separate. Now student is asking us to write the simplest form of this inverse trigonometric function. So student, in simplest form, we have some conditions here. Whenever we can see a condition which is in this particular form, a square plus x square. Here student, both constant as well as x square is positive here. So in this situation, we should take the value of x as a tan theta. If both are positive, then we should take the value of x as a tan theta. Why we should take a? Because here constant is a. Whatever the constant is there, that we will take as the value of x. If it is like this, a square minus x square, means constant is positive, x is negative, that time the value of x is a sin theta. If it is like this, x square minus a square, means x is positive, a is negative, our constant is negative. In this situation, the value of x is a secant theta. It means we should take only the ratios of trigonometric functions to x here. Co-ratios will not come. It will come, obviously it will come, but it will be very rare case. Depends on the situation. But for maximum problems, we will take like this ratios only. And whatever the constant is given here, if it is a here, then I should take a. If it is b, I should take b. If it is 1, then definitely 1. So these things are very important to solve this kind of problems. And this kind of problems are also called as method of substitution. Problems using method of substitution. Why it is called as method of substitution here? Because in this function, whatever the x is there, to that x we are substituting a trigonometric function. See here, you can just say this. We are substituting a function to x. That's why it is called as method of substitution also. So this is very, very important. Based on this, we'll solve the problems. You will erase this. So student, I will take the function in the solution. Tan inverse root of 1 plus x square minus 1 divided by x. Student, here a is positive and x square is also positive. So I will take, put x is equals to a tan theta, but the value of a here is 1. We'll take x is equals to tan theta. With this value, what do we get? Theta value is tan inverse x. I'll just shift this function to other side. That gives theta is equals to tan inverse x. Let us substitute these values here. Root of 1 plus tan square theta minus 1 divided by tan theta. So now I got a formula here. The moment I will substitute the value of x, then I will get a formula. If I am not getting any formula, then somewhere I am wrong. So I got a formula here, that is 1 plus tan square theta. And what is the formula? It is identity. From the SLC we are studying these identities. So it is secant square theta. So that is equals to tan inverse of root of secant square theta minus 1 divided by tan theta. Now square and root gets cancelled here. Then what is left out? Tan inverse of secant theta minus 1 divided by tan theta. Now student, here secant theta minus 1. So secant theta can be written as, so this is equals to tan inverse secant theta can be written as 1 by cos minus 1 divided by tan theta. Tan can be written as sin by cos. Now in the numerator we must take LCM. Here we must take LCM. So what is the LCM? Tan inverse 1 minus cos theta is the LCM here. So 1 minus cos theta divided by cos theta whole divided by sin theta by cos theta. Cos theta gets cancelled. So this becomes tan inverse 1 minus cos theta divided by sin theta. Now student, here we should apply the formulas. 1 minus cos theta. Student, I will write the formulas here. 1 minus cos theta. So I will use the formula of cos 2 theta. Cos 2 theta can be written as 1 minus 2 sin square theta. So here if I start shifting this, so minus 2 sin square theta becomes plus 2 sin square theta. This is equals to 1 as it is minus cos 2 theta. I am shifting to right hand side. That becomes cos 2 theta. But what do I need? I don't want 1 minus cos 2 theta. I just need 1 minus cos theta. That means I don't want this multiple angle. If you want to remove any multiple angle, we should convert it to half angles. So wherever angle is there, there I will divide by 2. Divide by 2. So it is 2 sine square theta by 2 is equals to 1 minus cos theta. No divided. 2 and 2 gets cancelled here. So student, 1 minus cos theta can also be written as 2 sine square theta by 2. With this same thing, I know what is sine 2 theta. It is 2 sine theta into cos theta. Now here I don't want again 2. There is this multiple angle I don't want. So just need sine theta. So sine theta can be written as 2 sine theta by 2 into cos theta by 2. So let me substitute here. Student, tan inverse, what is 1 minus cos theta? Here is the value of 1 minus cos theta. It is 2 sine square theta by 2 divided by sine theta is 2 sine theta by 2 into cos theta by 2. 2 and 2 gets cancelled. 1 time sine and 1 time sine gets cancelled. So what is left out here? Tan inverse sine theta by 2 divided by cos theta by 2. Sine by cos is tan. So this is tan inverse of tan theta by 2. So student, here tan inverse and tan gets cancelled. This property also we studied in our previous video. So whenever inverse function and trigonometric function same comes, both will get cancelled. But of course there is a range and domain for that. But here in general it is theta by 2. So the answer is theta by 2. What is theta? Theta is tan inverse x. So its final answer is okay, I'll write it here. So this is theta by 2. So its final answer is half tan inverse x. So student, the simplest form of this function is half tan inverse x. Okay, student, let us go to the next problem. That is, write the simplest form of function tan inverse 1 divided by root of x square minus 1. Here mod x is greater than 1. Mod x is greater than 1. This is the condition. Understand here, this time x square is positive, constant is negative here. Okay, I will take the function as it is. Now let me substitute the value of x. Put x is equals to secant theta. Put x is equals to secant theta because constant is 1 here. So directly we will take 1 secant theta. Then what is theta? Theta is secant inverse of x. So let me substitute here. Tan inverse 1 divided by root of secant square theta minus 1. So student, under the root we have secant square theta minus 1. What is secant square theta minus 1? Tan inverse secant square theta minus 1, that is 1 divided by root of tan square theta, is tan square theta according to the identity. So this becomes tan inverse 1 divided by square and root gets cancelled, 1 divided by tan theta. Student, we know what is 1 by tan. 1 by tan is, it is part. Tan inverse of cot theta. And student, in this kind of problems, like method of substitution, our target is to remove this inverse trigonometric function from the function. In this function, we should cancel inverse trigonometric function. Then we can write the simplest form easily. So here, to cancel this tan inverse, I should convert this complete quantity in terms of tan only. Now, but I got cot here, so we can use allied angles here. Because the other way of writing cot is tan inverse of tan pi by 2 minus theta. First quadrant all are positive. Tan 90 minus theta is cot theta. I'll write here. Tan 90 minus theta can be written as cot theta. First quadrant all are positive. And according to AST's rule, if it is 90 and 270, ratios changes to co-ratios. Now easily tan inverse and tan gets cancelled. Answer is pi by 2 minus theta. What is theta? It is here pi by 2 minus secant inverse x. So student, this is the simplest form of this function. Okay students, let us go to the next problem. That is third problem. The simplest form of tan inverse root of 1 minus cos x divided by 1 plus cos x, where here x is 0 less than x less than pi. Actually, it is very easy problem because he has directly given trigonometric functions. So we'll take the function tan inverse root of 1 minus cos x divided by 1 plus cos x, and this is the condition. Now student, here in the previous problem, we know what is the formula for 1 minus cos x. Similarly, we can easily write 1 plus cos x. So I'll write direct formula. So tan inverse root of 1 minus cos x, formula we got is 2 sin square x divided by 1 plus cos x is, it is 2 cos square x by 2. These are the direct formulas of 1 minus cos x and 1 plus cos x. This is possible with the help of cos 2 theta formulas. This we discussed in the last problem. So I directly wrote here. Similarly, we can get for 1 plus cos x. Now here 2 and 2 gets cancelled. Tan inverse root of sin by cos is tan. Both are having square here. So we can write tan square x by 2. Now square and root gets cancelled. So this becomes tan inverse of tan x by 2. Now inverse function and trigonometric function comes together, then both will get cancelled. Final answer is x by 2. So the simplest form of tan inverse root 1 minus cos divided by 1 plus cos is x by 2. Next problem, fourth problem. The simplest form of tan inverse cos x minus sin x divided by cos x plus sin x, and here the value of x is between minus pi by 4 to plus pi by 4. Sorry, it is plus 3 pi by 4. Now student, here tan inverse cos x minus sin x divided by cos x plus sin x, and between this value of x. Student, here whenever cos and sine comes, whether it is addition or subtraction, then our target is to remove cos from this. Our target is to remove cos. First target is that. The next is obviously we should remove tan inverse, and that is inverse function. So this becomes tan inverse cos x minus sin x divided by cos x plus sin x. Now student, as I said, our first target is to remove cos from this. So what the best method? Best is dividing cos x. Then we will see how to cancel tan inverse. So here I will divide cos x. So what do I get? Tan inverse cos x cancel, 1 minus sin x by cos x all divided by 1 plus sin x by cos x. We know what is sin by cos. Sin by cos is tan. Tan inverse 1 minus tan x divided by 1 plus sin by cos is tan. Now student, this 1 minus tan x divided by 1 plus tan x can be written as tan pi by 4 minus x. It is like tan a minus b formula. Tan a minus b formula. What is tan a minus b formula? Tan a minus tan b divided by 1 plus tan a tan b. Because I will write the formula here. Tan pi by 4 minus x is nothing but tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x. Isn't it? Now what is tan pi by 4? Tan pi by 4, that is 45 degree. Pi by 4 is 45. So tan 45 is 1 minus tan x as it is divided by 1 plus as it is tan pi by 4 is again is 1 into tan x. So student, 1 minus tan x divided by 1 plus tan x can be written like this. That's what, after this I directly wrote this. Now here inverse function and trigonometric function both comes together. So the next step is this pi by 4 minus x. This is the final answer, and this is the simplest form of this function. It is fifth one. Right, the simplest form of tan inverse 3a square x minus x cube divided by a cube minus 3ax square. Here the condition is a must be greater than 0, minus a by root 3 less than f less than a by root 3. So this is the condition. Here a is whatever the constant is there, that must be greater than 0. And the value of x lies between minus a by root 3 to plus a by root 3. So in this problem, we have constant, that is a. It is clearly specified, mentioned that a is exist here. So to this, in this function, whatever the value of x we will give, there the x should have this constant also. So solution, tan inverse 3a square x minus x cube divided by a cube minus 3a x square. Now student, here the value of x is, put x is equals to a tan theta. The purpose of taking x is equal to a tan theta here is, as I said, I have a in the function. So whatever I am giving values to x, there I should involve this constant also. With this, we will try to find what is our theta. So first, tan theta can be written as x by a. So obviously theta is equals to tan inverse x by a. So finally my theta is tan inverse x by a. Let us substitute x value in this. Tan inverse 3a square x is a tan theta minus x cube here, and x value is a tan theta. So it becomes a cube tan cube theta divided by a cube minus 3a x square. X is a tan theta, then x square is a square tan square theta. So tan inverse 3 a square into a is a cube tan theta minus a cube tan theta divided by a cube as it is minus a into a square is 3a cube tan square theta. Now student, here I can easily take a cube common. Easily I can take a cube common. So what do I get? Tan inverse of, if I remove a cube in the numerator, what is left out? 3 tan theta minus, I'm sorry, I should write cube here because it is a cube. Minus tan cube theta divided by a cube I will take common here also. Then left out is 1 here because a cube I completely removed outside the bracket. Then minus 3 tan square theta. Now straight here a cube and a cube gets cancel. So the remaining is tan inverse of 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Student, this complete has one direct formula. And what is that? In first PC we derived and we studied many times. That is tan 3 theta. So this is equals to tan inverse of tan 3 theta. Then this complete is the formula of tan 3 theta. It's a direct formula of tan 3 theta. No changes, nothing. And this we derived in the first PUC. Now again, inverse and function comes together. So both get cancelled. We'll get 3 theta. So what is the value of theta? It is here. So 3 as it is. Theta is tan inverse x by a. So student, the simplest form of this given function is 3 tan inverse x by a. Student, these are the basic problems of simplest form. If you understood this concept and the problems, easily you will get 3 marks in your second PC annual examination. As well as tan inverse x plus tan inverse y formula also. They will ask any one question with these 2 topics for 3 marks. So student, I hope you people understood the today's problems. If you have any doubt, you can put your doubt in comment box. Thank you, student. Another type of problems where we will find the values of the inverse trigonometric functions. So these are also very important problems. Let us discuss one by one. So in this, the first problem is find the value of tan inverse bracket 2 cos bracket 2 sin inverse half. Student, here there are 3 functions. First, the bigger function is tan inverse. The next is cos and the smallest is sin inverse. So student, here we will start with this smallest one. Inside the brackets we will give first preference. And he is asking us to find, combine together, what is its value. So solution is tan inverse 2 cos bracket 2 sin inverse half. So student, here first is, let me just first find what is sin inverse half. This is equals to tan inverse 2 cos 2 as it is, this 2 as it is, sin inverse half. What is sin inverse half? It is pi by 6, 30 degree. Sin 30 degrees 1 by 2. So sin inverse of 1 by 2 is in radian pi by 6. So if we cancel this 2 1 time, 2 3 times, the next step is tan inverse of 2 cos pi by 3. Now student, it is a trigonometric function. Here we had inverse function. Now it is direct trigonometric function with an angle pi by 3. We know pi by 3 is 60 degree. Cos 60 degree. Tan inverse this 2 as it is. What is cos 60 degree value? It is 1 by 2. Cos 60 degree is 1 by 2. We are very much familiar with trigonometric table. From 10th we are studying, so I don't think you have any confusion in this. So now this 2 and 2 gets cancelled. So the next step is tan inverse 1. What is tan inverse 1? This is just 45 degree, that is pi by 4. Because as I said, student, always our final answer must be in radian. If by mistake also if you write in degrees, it is totally wrong. So better we'll write the answer in radians. So the value of this complete function is pi by 4. Find the value of cot bracket tan inverse A plus cot inverse A. Then here cot bracket tan inverse A plus cot inverse A. He has not specified what is the value of A, but whatever it is, because whenever it is tan and cot, it is real numbers we will consider, isn't it? So let us not bother what is A value here, whether it is minus, plus, whatever it is. Cot bracket tan inverse A plus cot inverse A. Student, we have a property, we studied one property in inverse trigonometric function, that is tan inverse x plus cot inverse x. Answer is pi by 2. Answer is pi by 2 whenever this x is a real number. So student, anyhow we have not specified what is this A, so let us consider it is a real number. So in that case, this complete value will be pi by 2. Mention the property. According to this property, it is pi by 2. What is cot pi by 2? Cot pi by 2 is 0. How it is 0? Because tan pi by 2 is not defined. So the reciprocal of infinity is 0. Answer is 0. Find the value of right here tan half bracket sin inverse 2x divided by 1 plus x square plus cos inverse 1 minus y square divided by 1 plus y square. Condition is mod x is less than 1, y is greater than 0, x into y is less than 1. So it's a very standard problem. Tan half into sin inverse 2x divided by 1 plus x square plus cos inverse 1 minus y square divided by 1 plus y square. With these conditions, we should find its value. And students, in our inverse trigonometric properties, we know what we got this value as well as this value. In our first video, we derived these two properties or these two problems. So directly we will take that formulas. It is solution tan half sin inverse 2x divided by 1 plus x square plus cos inverse 1 minus y square divided by 1 plus y square. So I will write the direct value of this as well as this, because it's very standard problems. So tan half. So student, this can be directly written as 2 tan inverse x plus 2. This is in terms of y. So I will write tan inverse y. Student, these are the direct formulas for this as well as this. No changes, nothing, as it is. And in our first video of inverse trigonometric function, we derived all these properties. Now here, I can easily take 2 common here because in both the terms 2 exist. I'll take 2 outside the bracket equal to tan inverse x plus tan inverse y. This 2 and 2 gets cancelled. Then it has a direct formula, and in today's video we did problem based on this formula. What is that? Tan inverse x plus tan inverse y. What is the formula there? Tan inverse x plus y divided by 1 minus x into y. Now student, here trigonometric function and inverse trigonometric function. Trigonometric function and inverse trigonometric function exist. So both gets cancelled. The final answer is x plus y divided by 1 minus x into y. So student, the value of this complete function is x plus y divided by 1 minus x into y. Because the trigonometric and inverse trigonometric both are exist, so both gets cancelled. Finally, this is the final answer. Okay, student, let us go to the next problem. That is, find the value of x if sine inverse 1 by 5 plus cos inverse x is equals to 1. Friends, it's actually a standard result. Based on the property we can directly do, and according to that the value of x is 1 by 5. Value of x is 1 by 5 because we know that sin inverse x plus cos inverse x, answer is pi by 2. Then sin pi by 2, it gives 1. But since it is a theory problem, NCERT board exam problem, so here we cannot do direct, we should follow the procedure. But in case of CET exam or any competitive exam, we can directly write the answer according to the property. But here, let us use each and every steps. So this is the given condition here. Take sine into sine inverse 1 by 5 plus cos inverse x is equals to 1. Student, I will shift this sine function to other side. This sine function I will shift to other side. So it becomes inverse. Sine inverse 1 by 5 plus cos inverse x is equals to sine inverse 1. Okay, here it's difficult to find its angle, but here it's very easy. Sin inverse 1, it is what? Pi by 2. So this I will keep as it is. Plus sin inverse x is equals to pi by 2. Sin inverse 1 is 90 degrees. That is sin 90 is 1. Now I will shift this complete to this side. So cos inverse of x is equals to pi by 2 minus sin inverse 1 by 5. Now this cos inverse, just inverse trigonometric function, I will shift to other. X as it is. So my x is equals to cos pi by 2 minus sin inverse 1 by 5. So student, it is cos 90 minus theta. First quadrant it is cos 90 minus theta. All are positive. But whenever 90 and 270 comes, the co-ratios changes to its ratio and vice versa. So here I have cos. So the answer is sin, and this quadrant vanishes. This is the angle, that is value sin inverse 1 by 5. So student, x is equal to sin of inverse 1 by 5. Again, trigonometric function, inverse trigonometric function, both exist at one place, so both are gets cancelled. So the final value of x is 1 by 5. Find the value of x if tan inverse x minus 1 divided by x minus 2 plus tan inverse x plus 1 divided by x plus 2 is equals to pi by 4. So it's a very important problem, but it is based on again tan inverse x plus tan inverse y formula. With that formula, we should find the value of x, and the sum of these two things is equals to pi by 4 as given. Let us write this. Tan inverse x minus 1 divided by x minus 2 plus tan inverse x plus 1 divided by x plus 2 is equals to pi by 4. So student, this complete is x and this complete is y. So what is tan inverse x plus tan inverse y formula? So this is tan inverse of x plus y divided by 1 minus x into y. So finally it is tan inverse of x minus y by x minus 2 plus x plus 1 by x plus 2 whole divided by 1 minus x minus 1 by x minus 2 into x plus 1 by x plus 2. Because I consider that this is our x and this is our y. So this is x and this is y. So according to tan inverse x plus tan inverse y, I can write these things are like this. And this is equals to obviously pi by 4. Now student, here this tan inverse function I will shift to right hand side. It becomes trigonometric function. And in the bracket, whatever I written, I must take LCM. What is LCM? LCM is x minus 2 into x plus 2, both in numerator and denominator. So what do I get? X minus 1 into x plus 2 plus x minus 2 into x plus 1 divided by x minus 2 into x plus 2 whole divided by student, here denominator is x minus 2 x plus 2, that should be multiplied to 1 because it's a LCM. So this is x minus 2 into plus 2 minus x minus 1 into plus 1 divided by minus 2 x plus 2. So that is equals to tan pi by 4. Now student, here this denominator and this denominator gets cancelled. Now let us multiply this. Whatever the left out terms are there, let us do the simple multiplication. So x into x is x square, x into 2 plus 2x minus 1 into x minus x minus into plus minus 1 into 2 2 plus x into x x square x into 1 plus x minus 2 into x minus 2x minus into plus minus 1 into 2 2. And this is our numerator. Now denominator. And in our denominator it is a minus b, a plus b form. X minus 2, x plus 2 form. So I can write this as a square minus b square minus as it is. Then here again it is a square minus b square form. So what is tan pi by 4? 1. Now student, if anything is possible to cancel, let us cancel this. Plus 2x minus 2x gets cancelled. Minus x plus x gets cancelled here. The next is student, I will erase this. Now after this, I will continue here. What is left out here? X square plus x square. How much it is? 2x square minus 2 minus 2. It is minus 4 divided by denominator is x square minus 4 minus into x square minus x square minus into minus is plus 1 square is 1. It is equals to 1. And next is minus x square plus x square cancels in the denominator. So 2x square minus 4 divided by minus 3 equals to 1. So student, if I do the cross multiplication, what do I get? So this gives 2x square minus 4 is equals to minus 3. Just this minus 3 I cross multiplied to 1. So what is the answer I will get? 2x square is equals to minus 3 plus 4. Minus 4 I shifted to other side. It becomes plus 4. So at the end it is 2x square is equals to 1. So finally it is x square is equals to 1 by 2. X is equals to plus or minus root 1 by 2. This is the value of x here. Find the value of sine inverse sine 2 pi by 3. Sine inverse sine 2 pi by 3. Now student, here you cannot cancel sine inverse and sine. No, because we studied these properties only if it is satisfied, if it is comes in the range of this sine function. If it is beyond that, then we cannot write the direct answer. So if it is not like that, then what we should do? To this angle, we should convert it to allied angles. Then we should simplify it and we should bring it in its range. So let us see how can we do this. Sine inverse of sine 2 pi by 3. So student, here 2 pi by 3 is beyond minus pi to minus 90 to plus 90. So let us see how can I write this. Sine inverse sine. Student, I know that 2 pi by 3 comes in second quadrant. No doubt, it is in second quadrant. Because pi by 3 is 60. 60 into 2, 120. So 120 can be written as 180 minus 60. Isn't it? 180 minus 60 is 120. So now sine inverse of sine 180 minus theta. Sine 180 minus theta is what? Sine theta. Isn't it? Because in allied angle 180 minus theta is second quadrant, and 180 and 360 comes, function remains same. So with that, the answer is sin theta. So now here, see, this pi by 3 comes between minus 90 to plus 90. That is minus pi by 2 to plus pi by 2. So now you can easily cancel inverse sine function. So the final answer is pi by 3. Next question, similar to this. Find the value of tan inverse of tan 3 pi by 4. Student, tan also has the range minus pi by 2 to plus pi by 2. So here also it exceeds, it gives 145 degree. Because pi by 4 is 45. 45 into 3 is 135. So this can be written as, since it comes in second quadrant, so I can write this as tan pi minus pi by 4. So student, tan 180 minus theta. What is the answer? Tan 180 minus theta, it is tan theta. So now this pi by 4 is between minus pi by 2 to plus pi by 2. So you can directly cancel these two things. So the final answer is pi by 4. Same thing if it is in terms of cos inverse and cos with any angle, we should check whether it is in between 0 to pi or not. If it is more than that, we should again convert like this. Please find the value of cos inverse of cos 3 pi by 2. Okay. Find the value of cos inverse cos 3 pi by 2. So cos inverse cos 3 pi by 2. Student, here 3 pi by 2. Pi by 2 is 90. 90 into 3 is 270. So the range of cos is 0 to pi. Isn't it? Every function has its own range. So this exceeds pi. This value exceeds our pi. So let us bring this value in between this. So what I can do? I will convert this to allied angles. Cos inverse cos 2 pi minus, otherwise it is okay, 2 pi minus pi by 2, isn't it? 3 pi by 2 can also be written as 2 pi minus pi by 2, because if I take LCM, what do I get? 2 into 2 is 4 pi minus pi, it is 3 pi divided by 2. So now cos inverse, what is cos 2 pi is 360. Cos 360 minus theta. 360 minus, it is in fourth quadrant. In fourth quadrant, cos is positive. So what is the answer? it is just cos theta. So this can be written as cos pi by 2. So now, since this pi by 2 is between 0 to pi, so direct answer is pi by 2. Now, this time cos inverse and cos gets cancelled because it is between 0 to pi. So, answer is pi by 2. So, student, you should remember that if it is sine and tan, the range is minus pi by 2 to plus pi by 2. But it is in terms of cos means it is 0 to pi. So, student, next is find the value of tan sin inverse 3 by 5 plus cot inverse 3 by 2. Student, he is asking us to find the value of tan sin inverse 3 by 5 plus cot inverse 3 by 2 value. So here it is tan sin inverse 3 by 5 plus cot inverse 3 by 2. The student, here tan is there, sin and cot. Everything is totally different here. So it's highly impossible to cancel anything or to find. So what I can do here is this complete thing inside the bracket, let me convert in terms of tan inverse, because then this tan can be cancelled, or I will get one proper formula. So with that I can continue, but with this it's difficult. So to convert this two things in terms of tan, this is very easy, but this I should convert in terms of tan. So I will use one triangle. I will take this is alpha or some angle. So let sin inverse 3 by 5 is equals to theta. Then what is sin theta? Sin theta is equals to 3 by 5. Now students, sin theta is 3 by 5 means, we know sin is, what is the definition of sin theta? This is A, B, C, and this is right angle, this is theta. So sin theta is opposite side by hypotenuse side. So student, this is 3, this is 5. If this is 3, its square is 9, and this is 5, its square is 25. 25 minus 9. If I use Pythagoras theorem, then I will get 16. Root 16 is 4. So adjacent side is 4 I will get using Pythagoras theorem. AC square is equal to AB square plus BC square. Pythagoras theorem I applied here. With that I got BC is 4. Since I know all the sides of the triangle, so I can write tan theta here. Not only tan theta, I can write different functions also, but I will concentrate towards tan only because I have tan here. So tan theta is what? What is tan theta? It is opposite side by adjacent sides. It is 3 by 4. That means my theta is tan inverse of 3 by 4. So what is my theta? Here it is. So that is sin inverse of 3 by 5 can be written as tan inverse 3 by 4. So student, now this complete function let us try to change. And here there is a cot. Obviously cot also can be do by this method, but cot and tan are reciprocal, we know. And we have one property. Cot inverse of x can be written as tan inverse of 1 by x. According to that property, I write this as the given function can be written as tan bracket. This can be written tan inverse 3 by 4 plus. Student, here I have part inverse 3 by 2 can be written as tan inverse 2 by 3. How is it possible? Because tan inverse x can be written as part inverse 1 by x. With the help of this property, part inverse 3 by 2 can be written as tan inverse 2 by 3. Now student, here I have tan inverse x plus tan inverse y formula again. But this time my x is 3 by 4 and y is 2 by 3. Let us substitute. So it is tan inverse x plus tan inverse y. What is that? Tan inverse x plus y divided by 1 minus x into y. So just applied the formula of tan inverse x plus tan inverse y. Here x is 3 by 4, y is 2 by 3. Where is this? Now student, let me take LCM here. So what is the LCM? Tan inverse. LCM is 3 into 4 is 12. So it is 3 3 is 9 plus 8 divided by 12. All divided by 3 into 4 is 12. 12 into 1. It is 12 minus 3 2s are 6 by 12. Now denominator 12 and 12 gets cancelled. This is equals to tan inverse 9 plus 8 17 divided by 12 plus 6 is 6. Now student, here tan and tan inverse with 17 by 6. Actually it can be any number, real number. So both gets cancelled here. So answer is 17 by 6. Because it defines real numbers. Of course, for every real number, tan and tan inverse gets cancelled. So its answer is 17 by 6. So the value of this function is finally 6. Now student, I hope you people understood the problems of inverse trigonometric functions. And student, with this I completed almost all problems of your NCERT exercise. I hope you understood. If you have any doubt with these problems, you can put your doubt in comment box. So student, this finish our inverse trigonometric chapter. Next chapter we will start in next video. Thank you student.